Hi class, today we're going to learn about rocks. And I know some of you are thinking, hey, didn't we do that before Christmas break? We learned about minerals before Christmas break, and hopefully by the time we're done learning about rocks, you'll understand there is a difference. You're going to be taking notes on this note sheet right here, so please make sure that you follow along. If I go too fast, remember you can always stop this and write information down or back up if you need to. Here we go. What we need to know about rocks first is that basically they are a mixture of minerals. So we looked at the minerals biotite, hornblende, quartz, and orthoclase when we did our mineral sets. And here they are all together in one rock called granite. This is what granite looks like. So this diagram is showing you all of the different stuff that's inside granite. Okay, so it's a mixture, if you remember what mixture means. The real reason why we study rocks, because people go to college, they get degrees, and they spend the rest of their careers studying rocks, which is, wow, why would you do that? Well, because they tell us about several things. Number one, they tell us the environment that rocks formed in. Some examples here for your note sheet is that coal forms where there's lots and lots of plant material compacted together. And so when we find coal, we know there used to be a swamp. For example, 25% of the United States coal reserve that hasn't been mined yet is located in Montana, which seems awful weird because we don't have alligators here and we don't have swamps here. But what that tells us is that Montana used to be much warmer than it is today in the past when that coal was forming. Also, if you find the rock basalt, that's typically formed from a lava flow, so we know that there used to be a volcano there. Make sure you fill this information out on your diagram on your note sheet. The second thing that rocks tell us is the order of geologic events. So if they tell us the environment that the rocks formed in, then we can get an order of when those things happened. Was there a swamp first, a volcano first, a desert first, a lake? What was there? And we can tell that from the rock layers. The third thing that rocks tell us is when those events occurred, okay? And we use a couple of concepts that we're going to talk about later in this class called relative age and absolute age, and some ideas that help us understand the order in which these rock layers should be based on our understanding of how things happen. Okay, so there's three types of rocks, and you probably heard about these in sixth grade science class, but there's igneous rocks that form in volcanoes, and they form because of heat and melting and magma, okay? And there's sedimentary rocks, they form in water through weathering and erosion, and metamorphic rocks that form underground from heat and pressure. Why are rocks important to you and I? Well, we know a lot of reasons why minerals are important and all the different things that they show up in. So what do rocks do for us as humans? Number one, they're in building materials, for example, in your granite countertops. They are in roads and in sidewalks. Basalt is used in roads. Rhyolite is used in sidewalks. They're the aggregate, the crushed up material that we mix with the materials to then make the road or the cement. They have valuable ores like gold, copper, other things like that. The rocks eventually form soils that we grow our crops in. Rocks hold our groundwater, like here in Polson, where all our water comes from is from groundwater up from wells. And we can also use them in landscaping rocks, whether they're fill in areas where we don't have to water, like we'd use scoria, or larger rocks for landscaping walls and different features. So these are reasons why we use them. Now, we're going to switch to the back side of this paper, and we're going to learn about the first type of rocks, more specifics about them. One more. There is actually pumice in your toothpaste. It's helped to scratch and whiten your teeth, okay? So the first type of rocks is igneous rocks. What we need to know about them is they're formed after a rock melts. So melting must occur, and then that rock has to cool and solidify from magma or lava. Igneous comes from a Latin word ignis, which means of fire. So these are fire-formed rocks. They're melted from the interior of the earth, and then they solidify, and they're obviously associated with volcanoes. So here's some things that happen when what determines the properties of igneous rocks is how fast they cool, okay? If they cool underground and they have lots of time to cool, then their mineral crystals, they are large, like this piece of granite, okay? So that this formed underground, Okay, if they pour out on the surface temperature is much cooler than the magma, so they will cool much faster, and we get small mineral grains like this one, which is a piece of basalt from a lava flow. They can fast cool. If they fast cool, they will actually trap air in them, like this guy right here. This is a piece of scoria here. You can see all the air pockets in it. And also, we can have a piece of pumice is the same thing. It has air holes in it as well. And if they cool really fast, you don't get mineral crystals forming. You don't get air pockets trapped. They take on this glassy texture like this piece of obsidian. All right, so what are some properties? Some things I've already talked to you about. The minerals are evenly spread like this, so we don't have bands or stripes or globs. They're spread throughout. They might have air holes in them, like this guy right here. And they might have large grains that you can see, these large crystals, like in this one, you can see the speckled look to it. Or they might be small and hard to see, like this piece of basalt where you can't really see the different individual mineral crystals. They tend to have dull colors, so dark colors, grays, tans, blacks, whites, just not very exciting colors, nothing bright or vibrant. And what environments do we find igneous rocks in? Well, they form on the surface. They come out of volcanoes, and they cool quickly. These are what are called extrusive igneous rocks. If they're underground, they get insulated by all the overlying rock. They cool very slowly, and these are called intrusive igneous rocks. So those are your types of environments and the properties that you would look for to identify an igneous rock. So here's some basic information about the different types. The extrusive, remember these form on the surface. So we have ones that cool super fast. They have no crystals. They have a glassy texture. This is our buddy here, obsidian, okay? Or they can have no crystals of minerals, and they can have lots of air holes like pumice. They can have small mineral crystals like basalt here, or they can have large mineral crystals like granite does, okay? So these are the properties that you can have of igneous rocks. It's going to help you identify them and help you tell the difference between them and where exactly they form. So make sure that you get all this information down. What you're going to do now is the Igneous Rock Lab. It's set up in a Google slide. You can look at all the rocks in there and fill out the information on your lab sheet. All of that information is explained in the Google slide, and just follow along in your lab sheet, use these notes, use the information from the Google slide, and you'll have lots of success.